Today's lesson is 4.2, the unit circle. Our objectives here are to review basically the special right triangles so that when we come to class we will construct a unit circle. The special right triangles are listed here. If you have an isosceles right triangle, then each of the angles, all three of the angles, have to add up to 180 degrees. And since it's isosceles, that means that these two sides are the same. Okay, so there's a special relationship between the hypotenuse, which is this long side here, and the two legs. So this is the hypotenuse and these are legs. Okay, so what this says is that if this side is 1 long and this side is 1 long, then using the Pythagorean theorem to find the length of this side here, c squared is equal to 1 squared plus 1 squared, which c squared is equal to 2, c is equal to the square root of 2. So the length of the hypotenuse is square root of 2, and that is the proportion that has to do with a 45, 45, 90 degree. So in other words, if I had a triangle, an isosceles right triangle, and each side was 6, then the hypotenuse would be 6 square root of 2. And of course you could verify that with the Pythagorean theorem. But if you know the ratios of the sides, you don't really need to verify it every time. Okay, so we're going to do some more examples. The other one is the 30, 60, 90 triangle. Once again, 30 plus 60 plus 90 is 180. So you don't have to, this is a special triangle, and they also have a special relationship. So the side, the leg opposite the 30 degree angle, the leg is 1, if the leg is 1. Then the side opposite the 60 is going to be whatever this side is times the square root of 3. The hypotenuse of a 30, 60, 90 triangle is whatever the length of the side of the 30 across from the 30 doubled. So 2, 1 square root of 3, and the square root of 3 is across from the 60. And you should know this. I mean, this is just a scalene right triangle. All the sides are different, so this is a scalene right triangle. So for instance, if I had a 30, 60, 90 triangle, and this is 4, to find the other two sides, right, then I would know that the hypotenuse is always double. This is 30, this is 60 degrees. This is important. The side opposite the 30 is 4, then doubled, that would be 8. And the side opposite the 60 would just be 4 square root of 3. Now, an easy way to remember, because I have students who can't remember, is it square root of 2, square root of 3? If it has two sides that are the same, like this one right here, then you would have the square root of 2. If you have 3 different angles, scalene in other words, then you would have square root of 3. And that's just kind of a way, you know, like we did with complementary angles, to remember that. So here are the ratios. Be sure to get those down in your notes. Okay, so here are some examples that we can work together. Right here, number 4 is isosceles right. So in other words, it's a 45, 45, 90 triangle. And the reason I know this is because these two sides are congruent. So this is 45 and so is this, isosceles right. So that goes with the ratio. If these are congruent, then x is going to have to also be 6, and the hypotenuse would be 6 square root of 2. Easy. Okay, here's another 45, number 3. I know they're out of order, but I had a reason. Because this one looks a little bit different. One thing I do know about number 3 is that x and y are going to be the same, because they're across from angles that are the same measure. So to find this, what I'm going to do instead is that I know that 12 is going to equal x times the square root of 2. So I'm going to set up the proportion backwards. Just as here, x times the square root of 2 was the hypotenuse, right? So x times the square root of 2 was equal to 6 square root of 2, right? Then I know that x is going to equal 6. And so that's what I got here. If I set this same thing over here, when I divide, I'm going to divide both sides by the square root of 2. this is going to leave me with something that needs to be rationalized. So if I rationalize it, multiplying it by the square root of 2 over the square root of 2, then I end up with 12 square root of 2 over 2. 12 divided by 2 is 6 square root of 2. So that each side then is going to be 6 square root of 2. Now, do you see a pattern here? A pattern that might turn into a rule. Well, the rule might be that if this is a whole number, if this is 12, then in order to get the sides, I would take half of it and multiply it times the square root of 2. All right, so let's see if this works. So add another one. This is another 45, 45, 90 triangle, and this is going to be 10 long. All right, so if I use that same pattern, each side is going to be 10 divided by 2 times the square root of 2, or 5 square root of 2. 5 square root of 2. Okay, now if I do this one, and this is 10 square root of 2, what will the sides be? Well, the sides will just be 10. Take a look at those two examples and see if you can tell the difference between them. Remember that 10 square root of 2 is bigger than 10. Okay. All right, these are 30, 60, 90 triangles. Once again, they're out of order, and I've done this for a reason. Okay, so I'm going to give you one where the given side is across from the 30, because that honestly is the easiest. So you're going to take whatever this is, the side across from the 30, which is 8, and I'm going to double it, and that will be my hypotenuse. So this will be 16. And then to find the side opposite the 60, I'm going to take 8 and multiply it times the square root of 3. And I'm done. Now, I could have used the Pythagorean theorem to find those sides, and I would have gotten a decimal for this. There's no reason. You need to get an exact answer and use this pattern. So I'm hoping you remember this. Okay, so I'm going to do number 1 next, to find the side opposite the 60. And if you'll notice, I'm drawing arrows in here. And I'm drawing arrows because the side opposite the 30 is the main one. That's the one the other two are built on. So if I know that the hypotenuse is 14, I can work backwards. The side opposite the 30 is going to be 7. And once I know that, then the side opposite the 60 is going to be 7 times the square root of 3. All right, so look at that example again. Okay, now number 5. Number 5 shows me the side opposite the 60. Well, how do I get the side opposite the 60? Well, 4 square root of 3 is equal to the side opposite the 30 times the square root of 3. So what is y going to be, or the side opposite the 30? Well, if I divide both sides by the square root of 3, y is 4. And once I have that side, it's very easy then to find the hypotenuse. I'm just going to double it and make that 8. Okay, so I'm just working with the pattern. And if you didn't already know this pattern, it's going to be painful. But if you do, this will be a lot easier. And if you can learn it now, then it'll be much easier when we begin to use this. Example that I want to show you on a 30, 60, 90 triangle, and this is the most challenging. This is 30 and 60, not drawn to scale. You'll just have to bear with me. All right, so let's make this 5. All right, so the side opposite the 60 is 5. I don't know what the side opposite the 30 is, and I don't know what the hypotenuse is. I need those two. But I do know that the side opposite the 60 is equal to the side opposite the 30 times the square root of 3. Okay, to solve for x, I'm going to divide both sides by the square root of 3, forcing me to rationalize it. Which will be 5 square root of 3 over 3. And so this is going to be then the side opposite the 30. Now, to find the hypotenuse of that, remember, the rule is you take whatever this is, the side opposite the 30, and you double it. So 5 square root of 3 over 3 times 2 over 1 is going to be 10 square root of 3 over 3. Okay, look over this example, and we'll do some more in class if you're still having some issues with it. On the next screen, what I'd like to do is remind us a fraction. Rationalize a denominator. Rationalize a denominator. Okay, so if I have 8 over the square root of 2, to rationalize a denominator means to get the radical out of the denominator. So if I multiply it by itself, then what I end up with is the square root of 4, which is 2. And once again, no radical in the denominator. Well, if I multiply something, I need to multiply it by a form of 1 in order not to change its value. So this is going to be 8 square root of 2, which does not reduce, 8 square root of 2. But this time I have 8 divided by 2. Notice that they are outside the radical and they reduce. So this final is 4 square root of 2. Okay, 7 over square root of 3. All right, I multiply it times itself as a form of 1. That means that square root of 3 over square root of 3 is just equal to 1. And this is 7 square root of 3 over 3. Okay, go back over these and make sure you completely understand them. Write question marks next to anything you don't, and be prepared then to ask questions in class. See you then.